Okay, so I always think this is a strange question, but can you hear me back there? Like, yes? Okay, because if you can't, then you might not respond. All right, so are we all good? Everyone, does anyone need a break now? Okay, we'll have one out. Just after this, we'll take a quick 10-minute break. So again, my name's Conrad. I'm the agronomy advisor for Yolo, Sacramento, and Solano County. And thank you all for coming here. But I've had a couple growers talk to me independently, actually coming up to me and asking me about controlling rodent damage or kind of mitigating rodent damage to their drip lines. A lot of you not only grow wheat or sunflower or safflower, but you also grow tomatoes. Otherwise, you might not be able to make a living. You grow tomatoes or you grow some other vegetable cash crops, but you have to rotate through your crops. And so one thing I've been talking about with Gene Meow, if you all know him, he's the veg crop specialist and the tomato guy for the county, is that this is really kind of a systemic investment. And this is really this damage that you get to your irrigation lines is a perfect example of that. Wheat itself might not be worth the trouble to go fill up your profile or do these exclusions or anything, but when you come back around the next year and you want to grow your tomatoes and you want to get them in the ground at the right time and not spend thousands of dollars on labor, this is something that I think this is a really good example of how they're all tied together in terms of your budget, finance, and whatnot. So let's get started. We got a couple options that we can talk about. And the first one is thicker tubing. Pretty simple, straightforward thing. There was a study done back in 1990 in Florida State, and what we're looking at here is basically the damage that's caused by mice and rats versus a tube thickness of 4, 8, and 15 millimeters. The 15 mil is a pretty solid and thick line, right? But you can still get it. That's something that they do have available. I think Toro and I've got it on the next slide. But as you can see, with this increase in thickness, we see that there's definitely a correlation, a negative correlation with damage. So that's one option. However, I wouldn't put it past the mice. If it's fully exposed, they might still get in there and chew it up. This was for like surface drip, but if we're using subsurface drip and the soil is completely exposed and open, we can assume that it's probably going to be a similar environment once they actually get down in there. Rats, if we have problems with rats, I'm not so sure. I haven't heard of that as much. But okay, here's some of the costs that we're dealing with here. I just kind of ran this out and ran the calculation. What you're looking at is a lot of numbers, so don't sweat it too much. But on the left side, I've got the Toro 6 mil and the Toro 15 mil, and then I've got the Irritech 6 mil and Irritech 15 mil. And I looked those prices up, kind of priced them out to 1,000 foot, kind of what you were getting for 1,000 feet. And you can see Irritech is actually quite a bit cheaper than Toro. There might be some reasons for that. I'm not entirely sure. But if you're looking at, and this is with 12-inch spacing in between the emitters. That was the most common from what I heard, but this is 12-inch emitter spacing. But the take home on this is over here on the right. You have a cost of if you spread this out over 5 years, and I'm going on the assumption that you've got 7 workers, 5 days, 10 hours a day, 50 acres, and $13 an hour. So there's a lot of assumptions there. There was something like $91 an acre in labor to repair all of this stuff. With a 15 mil, I said maybe 25% of that damage was being incurred, right? It wasn't quite as bad, but you're going to get some standard leaks from valves and things. And when the shrink swell clays that we're talking about here are actually moving, you're probably going to get some leaks and damage from that as well. That's what we're looking at here. So the top number is after 5 years, the bottom number is after 10 years. And if we add labor into it, you can see that over 5 years even, the 15 mil is already saving us about $25 an acre. And $345 if that system lasts 10 years. That's pretty idealistic, and I don't know, you guys can shoot me down on this, that's one thing I also want you to encourage, because when we get to the end of this session, I want to spend 5 or 6 minutes talking amongst ourselves and then telling you that I don't know what I'm talking about. Because that's really the most helpful that I, kind of feedback that I can get from you guys. That, well, what about this or what about that, right? Because maybe I missed something. But that's okay. So here's our second option, pest eradication. First thing that you've got to do in order to eradicate your pest is identify what it is. I have a strong sense that these are mice, but they could just as well be voles that are doing this chewing damage in these shrink swell clays on these drip lines. So there's plenty of resources online, but essentially with voles, what you're looking at is they tend to have that shorter tail. They have more of these flat ears relative to mice. And you'll also find they tend to burrow kind of into the grass, and they create these little vole runs. That's kind of telltale of voles. You'll usually see that in those riparian areas or on the edges of your fields. That'll kind of indicate, well, maybe it's voles. You can also use traps to look for signs of specific. You can actually just kind of try and capture a few of them. You can use game cameras with wax blocks. I've got a slide on that in a minute. And it's kind of a joke, but you can kind of see what the cat's dragging in, get an idea for the population out there. But that's a standard meadow. Alternatively, we could be looking at mice, and there's a couple species of mice out there that are popular, but they're going to have similar kind of habitat and similar characteristics. The deer mouse has this white underbelly, a long tail, has some black streaks to its fur. Both of them have larger ears than the voles, and they have longer tails. They have kind of more of a pointy snout, but it's hard to maybe compare that if you're looking at the two of them, unless you have the two of them side by side, which might be unlikely. Also, this is kind of a mouse nest. They'll kind of gather some vegetation around a little cluster and go from there. And then that's a mouse burrow into hard ground. Okay, so here's an example of a motion sensor game camera. So if you're not using it to hunt, if it's not like elk season or whatever season, you can use it to hunt mice. Not as exciting, but there's a payoff. This is a wax block. You can see that they've cleared it out a little bit and then just kind of duct tape this thing on here to have a motion sensor kind of triggered. That'll then turn it on and take pictures, and you'll be able to see whether or not it's a mouse. You might not know if it's a deer mouse or a house mouse, but you'll probably be able to see whether it's a mouse versus a vole based on the size and also the chewing marks on the wax. That's a picture over there. This is probably diphacinone oats or something like that that's been laced. Issues with this, with the public and whatnot, and also with regulation, is the secondary toxicity risk. You may be familiar with that, but if an owl or a fox or a coyote ends up eating enough of these rodents that have been killed by anticoagulants, it'll go into their system as well and potentially cause them to bleed out. And it's just kind of a public relations nightmare. And we also don't want to see any non-target species taken out unnecessarily. Again, there's some trade names up top. Arrays, Prozac. All right, so another option would be exclusion, and this isn't something I'm super jazzed about, but it is something that might help kind of mitigate it. And the idea is pretty straightforward, but you've got fencing, basically create a little bit of a fence with aluminum flashing. You want about 10 inches out of the ground and 6 inches under the ground. And because voles and mice don't climb very well, they're not gonna really be able to get over this stuff. Netting and stuff like that, yes, they'll typically be able to climb over that, and so it's kind of not really helpful. Obviously, problems with this are getting your machines and yourself in and out of the field. So that's something you can, create access points around your field border, and depending on the value of the crop, I think that's something to consider. But when we're dealing with agronomic crops, it might be a little tricky. But one thing that is important, if you do ever use exclusion with aluminum flashing, you need to make sure that if say this is this strange shape with colors on it, this is the outside edge, this is this kind of grain, this would be like your vegetative stuff, your weeds, your mallow, whatever, just on the side if you haven't completely blasted everything. You need to make sure that there's a strip there that exposes the rodent. Think like a rodent, right? Like you don't want to be out there if you're completely exposed to hawks and foxes and cows or whatever. So for them to have an opportunity, they're not going to really take the opportunity to burrow underneath it. If there's vegetation right up to that point, it's nice and safe, they'll go dig, they'll dink around, they'll probably figure out a way into the field, tell all their buddies, and then it's a party again in your field, and you've just spent a lot of money on gutter material. So. All right, so here's the third option. This is the one that I think is probably the most intriguing, but I'm partial to soil scientists. So this is exclusion via managing soil moisture. These are called vertisols, and a lot of you know about them. We've got a lot of them in this area. From a soil scientist's perspective, it's really cool. From your perspective, it's not as cool. It's kind of a pain in the butt. Left side is you have vertisol that's pretty well hydrated after about, 6 inches, and it's closed up. But up top, you can see these cracks starting to form. This is an extreme version of vertisol with fairly large surface crusting going on. And as many of you know, you can see that many of these soils open up to the point where they could like break an ankle. Again, more. So what we're dealing with here is what's called a 2-to-1 clay. And we'll do a quick crash course on why this happens, but I won't spend too much time on that. This, essentially what we're looking at here is water content. This is gravimetric water content, so this is kind of the amount of water you have in the soil. As that water decreases, you have a volume. This is volume on this axis, and so as that water decreases, that volume then eventually hits a point where it really starts to drop off. And usually this happens pretty close to not long after field capacity. So it starts happening pretty quickly as soon as that water is moving away from those clay colloids. Everything stops swelling. But as that dries out, anyway. So and this, we all know this too generally. So in a soil, in any given soil, you got about 25%, you have a cube of soil in your hand, 25% of that is air, 25% of that is water if it's full, potentially 50% of it's air if you've put it in an oven. And then you've got your 50% of solids, roughly. All right, so here's the 2-to-1 clays. These are these ones I was talking about that have that montmorillonite mineralogy in them. You have the Cape clay, the Brentwood, and the Myard. The take home on this is they're common around this area. And as a result, this is for anyone who's in this area, you know if you have these clays or not because you've dealt with this. But if you're looking at your soil report, that's kind of what you're looking at, is these three, Brentwood, Myers, and Cape. Those are kind of those set off. Stuff. Okay, so I did a little home experiment and did just kind of like a continuous drying and soaked these things up to field capacity, drain them out, let them drain out with gravity, and then I started putting them in an oven. Maximum field capacity was about 48%. That's when I let them drain for about 24 hours, they were about 48%. Of their weight was water. Their volume was water. I calculated it for volume. You can see pretty quickly these soils start to crack. Okay, down to we found that, this is kind of danger zone area, like 39, 40. These. To kind of know these numbers, if I put through this, and you start calculating your number of emitters, and you say per emitter, how much volume do I need to fill? And okay, so it's a little bit of arithmetic. We don't need to dwell on it too much. But if you theoretically figure out how much water you need to apply in every single emitter, then you can say like, all right, I can keep it dry up top, or mostly dry up top, still get access in the field. You don't want to flood the thing out because you're not going to be able to get in there and harvest it. So this is really like precision ag, where you're just spoon feeding a little bit of this soil to keep those things closed, but then let it stay fairly dry up top. And that's something, I mean, I want to run more field trials and actually look at the applicability of this, but I think it's worth a shot. And less is probably more in this case, because you don't want to waste water, you want to allow your wheat to shut down, you still want to be able to get in the field. So the fourth objective is saving your drip line, but long term that's pretty expensive. Does that kind of answer your question? Like if you can get it to shut down, you're still pushing that KPA pretty low, and that's only mainly in kind of the top surface of the soil, and hopefully that biology of the wheat will just kind of say, all right, it's seed setting time. Same thing with sunflowers. You can't really give it more water once it starts to mature and shut down. It's not going to give you more yield. It's not going to be pulling that water up. It's not really going to be doing anything with it. Right? So forcing it to shut down and then keeping those soils closed up enough, I think would be the key. One of the problems with that, though, is that if you're dealing across a field with, say this is all clay. Let's just pretend that this is all clay. But this is 30% and this is 50%. It's hard to keep track of that. It's all clay. It's all going to shrink and swell. But where is it? And that is one of my arguments for having a soil map. And the soil survey did a good job of this. But they might say this whole thing is Kpay. And when you go look at the lab tests and stuff on the soil survey, yeah, you're going to have some estimates on your clay, but you're not going to know what your clay percentages are. And so you're not going to have an idea which soils are going to crack first. If they have more clay in them, they're probably more likely to crack first. But that's also going to take I wouldn't say that necessarily 100% one way or the other, but that's something you need to kind of look into and pay attention to. And I would say maybe 2 moisture sensors, one in your low area and one in your high area. Just kind of keep an eye on those, and then you can kind of spoon feed that water throughout the season. So it's an idea that I have, and I'd like to try it with growers over the season, but we see how we go. Our fourth option is similar to.
Can I ask a question?
Yeah, go ahead. This is the last slide.
Okay, go ahead.
So the fourth option would be doing kind of the same thing, where you're spoon feeding that wheat or that sunflower or that kind of dry down crop. Now sunflower would probably actually go too late, but wheat in particular. You're spoon feeding that wheat. You get it out of there by like mid-June or the end of June. Cross your fingers. And then harvest that, prep the soil, do your beds, get everything ready, and then throw a bean crop down. Your beans are going to struggle because it'll be hard with the planting date. The irrigation line spacing is an issue. Pre-irrigation with sprinklers is going to be an extra cost. But that's another thing to consider that I would like you guys to shoot down and tell me that being silly. But based on that, we have black-eyed beans. Baby limes are a bit long season, but black-eyed beans are 75 to 88 days, 90-day beans. Short season corn, some California light red kidneys, I think are also about 100 days. I didn't get that one. But filling that profile up, planting into moisture, and then cultivating for weeds, that allows you to kind of roll over the top and kind of just keep the soil closed up. Or even just dragging harrows over the top of the soil and filling that soil up, or kind of filling it up with more soil, kind of backfilling those cracks is another option that we could think of. So the problem is with that backfilling is that you need to still keep it. You still need to protect the drip lines up until that point. So before the wheat is harvested. Does that make sense?